Hello, everyone. I thought I will go ahead and explain formal charges in this little video because it seemed like that was an issue with everybody. So formal charges are charges that are assigned to individual atoms in any compound. Okay, so whether it's a neutral one like carbon dioxide or something that is a polyatomic ion like sulfate, it doesn't matter. Each of the atoms will have a formal charge. Now, this charge that is on the sulfate, that is not a formal charge. That's the totality of the formal charge. So there must be two negatives somewhere in sulfate. Carbon dioxide does not have a formal charge, or it doesn't have, a total charge. So it means everything must add up to 0. I'm going to do both for you, okay? So you can see how this works. So this is my quick way of doing formal charges. First of all, if your Lewis structure is not correct, then your formal charge is not going to be correct. So make sure your Lewis structure is correct. The best way to draw the Lewis structure is the lines. You can draw the dots also like this, let me cross that out. You can draw it this way too. I find that a little tedious. So I prefer to draw the line structure. So I encourage all of you also to do the same. You will see in the long run, it's going to be a lot more easy for you if you go ahead and write the line structures, okay, with individual lines as a pair of electrons. So each line is a pair of electrons, okay. So let's do the formal charge. Now, I hope you agree with me that this oxygen and this oxygen are exactly the same. So which means I just need to calculate for one and it'll be the same for the other. Okay, so I told you there is a formula that you can use. I will use mine, okay? So which means that I'll start with valence electrons, which is VE. And the valence electrons for oxygen are going to be 6 because it's in group number 6. Then I look for bonding electrons. And the way I look at bonding electrons is how many bonds does it have? So it has 2 bonds, and so it means it has 2 bonding electrons. In the textbook, you will find that it takes all the bonding electrons and then divide it by 2, which means what it is saying is that if you have a double bond, you have a total of 1, 2, 3, 4 electrons. So you take the 4 and then you divide it by 2, which still gives you 2. So mine is a little bit of a shortcut. So you just count the number of bonds. So it's 2 bonds. And then you write the non-bonding electrons, okay? So the non-bonding electrons, Ne, that's my short form for that. And the non-bonding electrons here in oxygen are 4. And the 4 would be the 1, 2, 3, and then 4, okay? And then you subtract, and that's a 0. So the same thing you do for carbon then. So the valence electrons are 4, and that's because it's in group number 4. How many bonds does it have? It has 4 bonds. So that's 4 bonding electrons. And the non-bonding electrons, there are none left. So that's a 0. Okay, so then this oxygen is also going to be 0. So that's how you get the 0 formal charge on carbon dioxide, except that each of the atoms is also a 0, okay, in there. So that's one. Okay, now let's talk about the sulfate ion. So in the sulfate ion, the first thing is to draw the Lewis structure, which if you need some help with the polyatomic Lewis structures, then, go through my pencast on that one or the video that I have. So right now, I'll just go ahead and write the, I don't know why it's doing that. There we go. So start off like this with 4 oxygens. That's what I always do. And then I know sulfur is in group number 6. Sulfur is also in row number 3, which means it can have expanded shell. So what I try to do is make my oxygen the octet, which it should be the octet, right? Sulfur should also be an octet, but sulfur can also have an expanded shell. Then remember, you also have 2 extra electrons coming from the 2 minus, okay? So the best way to do polyatomic ions is electronic bookkeeping. So I've gone through all of that and how you write the Lewis structures for that. But anyhow, so let's just presume that you know how to write the Lewis structure. So this is what you will come up with, okay, eventually as the Lewis structure. So now what I want to highlight for you is that these 2 oxygens are exactly the same. And then the other 2 oxygens here, these are exactly the same, which means I'm trying to cut down my work, okay, here. So I don't have to do all of them. So I'm going to go ahead and do the yellow one first. And so I just make a table like what I've done over here, and I would encourage you to do that. It keeps everything kind of organized. Okay, so you have the valence electrons, the bonding electrons, and the non-bonding electrons. Okay, so you choose each atom. So here is the double bonded oxygen. We will do the sulfur, and then we'll do the single bonded oxygen. Okay, so we'll do the 3 atoms just side by side. So the valence electrons for oxygens are 6 because it's in group number 6. The bonding electrons in the yellow one are going to be 2 because it has 2 bonds, so that's 2. The non-bonding electrons are 4 because it has the 2 lines in there, so that each of the line represents, again, 2 electrons, so that's a total of 4, that's 0. Then for sulfur, again, the valence electrons are 6 because it's in group number 6. And then how many bonds does it have? It has 6 bonds over here. So that's the bonding electrons that it's supposed to have. And then the non-bonding electrons, there are none left because if you count, there are 1, 2, 3, 4, 5, 6 electrons, right? So all the 6 electrons are bonded. So there is no bonded electron left in there. So 6 minus 6 minus 0 is also equal to 0. Let me put the minuses here also. Okay, and then lastly, now we are remaining with the oxygen. So in the last oxygen, we have again 6 valence electrons. That doesn't change at any time. How many bonding electrons? We have only 1 because there is only 1 single bond. And then how many of the non-bonding electrons is going to be 6 because you have 3 lines. 3 lines meaning 2 times 3, and that is 6. So 6 minus 1 minus 6 gives us minus 1. So it means that 2 of the oxygens, let me pick another color here. So 2 of the oxygens have a formal charge of 0 and 0. The sulfur is a formal charge of 0, but then the oxygens which are single bonded are going to be minus 1 and minus 1. So formal charges are really helpful in targeting which atoms really have the charge. So when you say 2 minus, on a polyatomic ion, where does that 2 minus belong? Is it on sulfur? Is it on oxygen? Which oxygen? That kind of thing. Okay, so I hope I made this a little bit easier for you, and it should be that easy. Okay, don't make it harder for yourself. All righty, let me know if you have any questions.